Oaks in the house.
And MoNaCo in the yard. We're talking about acids and bases. We're hitting up your vocabulary today in this video.
Homework number 2.
Yep.
Page 4 and 5.
You got to know what vocabulary is testable, and there are more than 20 words. So on your quiz, expect a few of them to be thrown out. Probably the ones that are repeated from a different unit.
Well, no, there's only 20.
There's only 20 in this one? I thought I had more than that.
Next, yeah, you're already thinking
Oh,
phonetics.
oops.
It's all right. Acidic, first one, we've heard of acid before. Specifically, if something is acidic, it will have properties of an acid, being that the pH will be lower than 7, it will be sour, and it'll have this H plus or this H3O plus ion in solution.
Very important.
Yes, all those things for acidic.
Basic. Well, it has the properties of a base, pH higher than 7, so 7 through 14. Bitter and slippery, OH negative in solution. What it produces.
There you go. Alkaline is just another fancy word for basic.
Yep.
If something is alkaline, we test its alkalinity. We're just talking about how basic it is.
We love talking about things that are basic this unit. Y'all better not be basic. Arrhenius acid. This is the chemical that produces H plus / H3O plus in aqueous water solutions. It is the definition of one type or one theory of acids. So when we say Arrhenius acid, we're talking about acids that produce this in solution.
Correct. Same thing for base. It's the chemical that produces OH ion in aqueous water or solution. So Arrhenius, that particular theory's version of base, this is the definition.
OH negative, which was what we said for acidic and basic. So Arrhenius theory is like the main theory we're going to work with this year that you really got to know. Visually, they're easy to identify. So what is the hydronium ion? Well, there it is. It's H3O plus. It's synonymous with H plus ions in aqueous solution because H plus ions react with water to make H3O plus.
Yeah, we're going to actually show you that in the next video a little bit more graphically. Going back to Lewis dots.
So right, an acid that's Arrhenius produces H plus ions in solution, which then react with the water molecules to make the H3O plus, which is why they're the same thing.
They're the same thing. When I say synonymous, that's what that means. Same thing. So they go hand in hand.
Yep.
Hydroxide ion specifically is that OH ion in solution. That is on table E. We've heard of this. We've seen this hydroxide before.
Yep.
Okay.
So there's an alternate acid-base theory. You'll see it referred to as the alternate acid-base theory.
Has a name,
we, as chemists, want to give some props to the folks who figured it out. It was Bronsted and Lowry. These guys made a theory that was a more robust explanation of acid and base behavior. It was a better theory than Arrhenius is.
Better in the fact that it encompassed all acids and bases. It didn't, it didn't leave some out by chance.
It explains the exceptions that Arrhenius couldn't.
Correct. Yeah. So that's the one you and I actually
like to use.
But it's our default.
Yeah,
but
that's what we think like.
The course wants you to know the other one.
Right.
So specifically, under the Bronsted-Lowry definition of an acid, it will become an H plus donor in solution. Hence, it gives off H plus. It's very similar in definition
to the Arrhenius.
And here's where the change comes.
Here's the big difference. Bronsted-Lowry base, or the alternate theory for acids and bases, says that a base is an acceptor of an H plus in solution. So it doesn't have anything to do with the OH negative, but it'll take the H plus from an acid, which is kind of like how acids and bases work.
Right.
Acids give up H pluses, bases take them.
And we'll see in the notes later, next video, how this will actually form an OH. But it's not directly, it's almost indirectly.
Right.
Because I don't have the OH in me that just comes off of
It plays games with water.
Yeah.
Bronsted-Lowry acids and bases play off the fact that the water molecule
has both an H and an OH in it.
And it's I didn't put this word in there, it's amphoteric.
Ooh, here we go.
Amphoteric. Anyways.
Electrolyte, we've seen this. Any chemical that dissociates in water, enabling the solution to conduct electricity.
Acids and bases are.
They are, because they will dissociate into their ions. We will find out that it's probably the only covalently bonded type of a atom, right? No metals.
Only covalent compound that can dissociate are acids and bases.
So that's what makes them so
special. And for that reason, they are weak electrolytes because they're covalent, not ionic.
Yeah, but that H plus is going to work very much the same way.
Yeah.
So
an indicator. Well, that is, an indicator. It's a color-changing substance that indicates if a solution is acidic or basic. You've used this with pH paper a billion, trillion, zillion times, I hope,
Yes.
in your living environment classes. A little paper to change the color, and
Right.
you compare it to the key.
Unfortunately, our reference tables talk about a few other ones.
Yep, which
that
are
a little bit
all-
more specific
Yeah.
in pH range to
Right.
help us hone in on what
And you'll
the
get to
actual
play
pH
with
is.
those in lab
In lab, yes.
or activity.
Neutralization, this is specifically when I take an acid and a base, they come together forming a salt and a water.
Mm-hmm.
Every time that is what happens, those products are the same.
Mm-hmm.
And if I take it all the way to the end, the H pluses and the OHs combine, making water neutralize out.
They cancel each other out.
And we get a pH of 7 now as opposed to acidic or basic pH.
The neutralization reaction is really useful to use the Arrhenius theory from, and you'll see why when we get there.
Yeah.
But pH scale, this is where we got to understand pHs in terms of a theory, not exactly acid or base, right? Okay, we get a pH number, but we need to know what the number means. It's related to a logarithm.
Yep, the negative log.
Negative logarithm of the concentration of the H plus / H3O plus.
Yep.
And it ranges from 0 to 14, giving a value and a number on how acidic or basic something is, which is relating to the concentration of those positive and negative ions in there.
Correct.
So you'll get a better understanding of that in that video. But
Yeah, I missed the rectangle with the triangles that they used to have in the reference tables.
Mm-hmm.
It had that diagonal line. It really
Yeah.
helped. I like that one a lot.
Yes.
Titration, this is a technique where a solution of known concentration can be used to determine the concentration of an unknown concentration. This will be lab.
Yeah.
The first lab that we do, yeah.
One or two of them. We'll
Well-
probably do indicators before we do
Oh, yeah, maybe.
the titration, because the titration requires you to use an indicator.
Oh, good call, good call. Different
So
kind of
in this titration, it's a rite of passage here.
Yeah, it's really good. You're going to learn how to use
Fun,
a burette.
it's pretty.
It's like a cool graduated.
Those of you who are precise
Piece,
will get great
right.
results. Percent error is a huge part of this one. If you sloppy, your percent error is going to be
Yeah,
huge.
but at the same time, you can run 3 trials rather quickly, and it's good. So
What's the salt? Not a salt. A salt is a generic term for any ionic solid. It is one of the two products of a neutralization reaction.
Right,
You'll
be it
see
soluble or not.
how it goes. They're similar to just double replacement reactions, but not quite.
Yeah,
You'll
they're
see
really
how it
close.
works when we get there.
Really close. Dissociate, again, is to break up into a chemical's constituent ions in solution.
Okay.
I don't just dissolve, it goes a step farther and dissociates.
Dissociate. So acids and bases dissociate,
Correct.
just like salts and ionic compounds dissociate.
Correct.
Beautiful. Ion review, so element that has gained or lost an electron. The most important ion, I think, in this unit is the proton
Yes, the H plus.
ion. Yeah, it's a hydrogen atom that's lost its electron, and now it's just a little proton, H plus, hanging
Just a
around.
proton. We're going to say that synonymously.
And then it reacts with the water molecule to make H3O plus, so it's
Yep.
important.
Oh, yeah. Molarity from last unit. Measure of concentration, the moles divided by liters.
It's important because acids and bases are compounds dissolved in water, so you got to have a concentration for it.
Sure, and 1 molar acid is not as concentrated as 12 molar acid.
Yeah, we won't be using 12.
No,
Probably
no,
won't even be
no.
using 1.
Well,
maybe.
Maybe.
We'll see.
We'll see.
You'll have to tell us when you do your titration.
Yeah, there you go.
What was the
There you
concentration?
go.
How much solute per unit of solvent? So again, molarity is a measurement of concentration. It's just to kind of get you thinking about how much of this stuff is dissolved in there, more or less.
Yeah, that's what concentration really is. So there's our key vocab words for this unit, guys.
Don't waste time. Vocab quiz is printed. You finish this video, do your quiz, move on.
Seriously. As
Yeah.
soon as you're confident that you know what these words
Yeah,
are, let's do
please
it.
study.
A few days.
And it's not open
Yeah.
notes. Be honest with yourself. Do it
Just
right.
don't take too long that you start to forget it. I mean,
Don't waste time.
yes, you
Moving
might have to
forward.
study for a day afterwards, great, but you're doing it quick. See you guys.
See ya.